Okay, so we're going to do a lesson on the periodic table. This is the basis of all of chemistry. So understanding the periodic table will be able to help you to understand chemistry. So this will be our first lesson. Right. So let's start off by just talking about the basics of an atom. Now, an atom has protons, which are positively charged, and neutrons, which are neutral, hence the name. And we can have more neutrons than protons because they are neutral, so they do not affect the charge of our atom. We also have electrons. Now, our electrons are in shells or orbitals surrounding our nucleus of our atom. So this is our nucleus, and these are our shells. Now, the shells hold the electrons. Now, electrons are negatively charged, and there are the same number of electrons to protons, which is why all atoms are neutral. Okay, so why is this relevant to the periodic table? So there are a few things on the periodic table which we need to care about. We care about the group number and not so much the period. However, it is important to know when you get to higher level science. So our group number tells us the amount of electrons in the outer shell. Sometimes the outer shell is called the valence shell, but this just means the outermost shell of the atom. So in this case of this atom, this would be our outer shell. And then the period tells us the amount of shells in the atom. Now, you may see that sometimes in exam questions, they will refer to the subatomic particles of an atom, and they will ask you to describe an atom in terms of its subatomic particles. When they're asking you about that, they're asking you about the amount of electrons, the amount of protons, and the amount of neutrons in that atom. Okay, let's go back to our periodic table. So this is our periodic table. This is one taken from the AQA exam. So this is one of the inserts that they would give to you. Don't worry if you're not on AQA, Edexcel will also give you the same thing, and same with OCR at GCSE and at A-level. Now, each tile on our periodic table, tiles end up looking like this, have two numbers. We have the number on top and the number on the bottom. The number on the top tells us our relative atomic mass. Now, the best way to remember this is that if we think about our subatomic particles, we have electrons, we have protons, and we have neutrons. Now, electrons have a negative charge. Protons have proton positive, have a positive charge, and neutrons neutral have no charge. However, electrons are so small that their weight is negligible. Okay, so we can say in terms of this lesson, electrons have no mass, which is not true, but bear with me. Protons have a mass of 1 and neutrons have a mass of 1. Now, if we think about the fact that only protons and neutrons have mass, then our relative atomic mass must be composed of the amount of protons and the amount of neutrons, as they are the only things with mass. Then, if we have a look at the atomic number, now for AQA, they tell you that the atomic number is the proton number. And if you remember before, I said that the amount of electrons and the amount of protons are equal, so that we have an overall neutral charge in our atom. So our atomic number, which is the bottom number, is equal to our protons, which is equal to our number of electrons. Because again, we want this charge to be equal. Now, if that is too complicated for you to remember, the big number is always the atomic mass. The small number is always the atomic number. Now that we understand what the tiles actually mean, we can go through and talk about the groups as well as the periods. So the groups run horizontally across the periodic table. Now for AQA, they're labelled. I also believe they're labelled for all of the other exam boards. So we have group 1, group 2, group 3, all the way to group 0. Now, group 0 is sometimes called group 8. So if you see it called group 8, they're the same thing. Now, the group number tells us the amount of electrons in the outermost shell of our atom. Running vertically, we have periods. Now, the period is the amount of shells in each atom. And period 1 starts with hydrogen and helium, boron to neon, and so on and so forth, all the way down. Another thing we need to know is where the metals and non-metals are separated on the periodic table. Now, I always found this really hard when I was at school, but the best way to do this is to have a look. It's kind of like a staircase. So we know that aluminium is a metal because it's what Coke cans are made out of, and it creates a staircase down till we get to here. Now, this pink block is all of our non-metals. Everything else is our metals. Understanding which are non-metals and which are metals is important when we talk about bonding, which we will do in a separate lesson. Now, if we have a look at our periodic table, there are only a few of these groups that you actually need to be able to name for your exam if you're at GCSE level. So this middle group here is our transition metals. Now, the transition metals aren't so interesting at GCSE, so I wouldn't worry about them too much. You just need to understand the properties, which I will also do in another video. Then we have group 1. Now, group 1 is our alkali metals. Group 2 are our alkaline earth metals. In the middle, we have our transition metals. You don't need to worry about anything between group 3 and group 6. Group 7 are our halogens. Group 0 are our noble gases. You just need to be able to name these for GCSE level. Another thing you need to know is the way the reactivity changes as we move down the group for group 1, 2, 7, and 0. So for group 1, our alkali metals, as we move down the group, the reactivity increases. This is also true for our alkaline earth metals in group 2. And if we have a look at group 7, as we move down the group, our reactivity decreases. This is a common exam question, and often they want you to be able to explain why this happens. Now, let's have a look at 2 elements in our group 1. So if we have a look at, let's say, sodium and cesium. Now, if we compare the atomic mass and the atomic number of both sodium and cesium, we see that cesium is much larger than sodium. Now, as it's larger, it means it has more protons, more electrons. And the electrons are further away from our nucleus, which means we have increased shielding. Essentially, if we have a look at it, if we look at our periods to help explain this. So, sodium is in period 3. Cesium is in period 6, which means cesium has 6 outer shells and sodium has 3. If we move from 3 to 6 outer shells, we have a lot more shielding. Essentially, imagine we have 6 doors that are closed rather than 3 doors that are closed. It's going to be harder for you to get out the exit. This is kind of true for our atom. Rather than them wanting to escape, they're so far away from the nucleus that they don't really want to be there. They've decided that going through the 6 doors isn't worth it, so they want to go somewhere else. So cesium is a lot more reactive than sodium because there is so much shielding. And this is also true for group 2. Now, if we have a look at the non-metals, because the bonding is different, because they don't follow metallic bonding, they react differently. So as you go down the group in group 7, the reactivity actually decreases. Now, when we looked at metals, the reactivity increased because the electrons were further away from the nucleus and there was more shielding. So the outer electrons would rather bond with something else. Whereas in group 7, as we go down the group, our atoms also get bigger. but non-metals react differently to metals. The bigger the atom, the more electrostatic attraction between the outer electrons and the inner electrons, and it creates a pull. So here I've drawn two simplified models of the atom. I haven't drawn all of the electrons, and I've only drawn a positive charge for the nucleus and a negative charge for the electrons. Now in metals, as we go down the group and the atom gets larger, the reactivity gets higher because these outer electrons are more happy to go somewhere else. They don't see the point of trying to pull close to the nucleus. And this is something we call shielding. So the shells create like a shield between the nucleus and the electrons between the charges. Now, if we have a look at nonmetals, it's actually opposite. In nonmetals, as we go down the group, the reactivity decreases. That's because the outer electrons have more of an affinity for the positively charged nucleus. And therefore, the more outer electrons we have, the stronger this charge. This charge is called electrostatic attraction. It's essentially the same idea as magnets. That concludes our lesson on the periodic table. If you have any other lessons that you would like me to do, please let me know. And if you found this one helpful, leave us a comment and give us a like.